This is NSAA 2021, Section 1, Question 54. So, propene burns in air. Each mole, when burnt, releases 2,000 kilojoules of heat. We're told that 2.1 grams of propene is burned to heat 100 grams of olive oil. The olive oil starts with its initial temperature being 22 degrees Celsius, and it takes 2 joules to heat 1 gram of oil. We also have the molecular weight of propene there, and we asked to work out what is the maximum temperature reached by the oil. So, what information do we have, and what equations can we put together to work out the maximum temperature that could be reached by the oil? Well, we have the mass of the oil, we have its starting temperature, and we have how much energy it takes to heat 1 gram of it, which is the same as the specific heat capacity. So if we put those all together, we can have the equation Q equals mc delta T, which is energy equals the mass times the specific heat capacity times the change in temperature. Now we have the mass, we have the specific heat, we want to find the change in temperature. Can we work out what the energy might be to solve this equation? Well, what do we know about energy that the question gives us? The only thing about energy we know is up here, that 2,000 kilojoules of energy is released when each mole of propene burns. So we find out how many moles of propene we have, we can find the energy released. So, how do we find the moles of propene? Well, we can use moles equals mass divided by mR. So we get 2.1 divided by 42 gives us 0.05 moles. And to find the energy release, we just have to times that by 2,000. So we have 100 kilojoules of energy released, or 100,000 joules. So now focusing on our equation, we know that the energy is 100,000 joules, our mass of oil is 1,000 grams, our specific heat capacity is 2, but what is our change in temperature? Well, if we plug those into the equation, and simplify this down, we get that 100 equals 2 times delta T, or 50 degrees is the change in temperature. So if the starting temperature is 23, that must mean that the original temperature was 73 degrees Celsius. So that's our final answer, which gives us an answer of E.